In this lesson, I want to show you how to write the balanced or the net redox reaction when the reaction is taking place in acidic medium. So there are some steps to take. The first thing that you need to know to do is to separate the oxidation half reaction from the reduction half reaction. And we use oxidation numbers to do that. So what's the oxidation number of the chromium in dichromate? +6. And there it changes to +3. So a decrease in oxidation number means a gain of electrons. So this is our reduction half reaction. What happened to the sulfur's oxidation number? It went from -2 to 0. So it increased, and an increase in oxidation number means that it lost electrons. So this is our oxidation. Our oxidation half reaction would be taking H2S to S, and the reduction half reaction takes dichromate Cr2O7 2 negative, takes it to Cr3 plus. So I've separated the oxidation half reaction from the reduction half reaction. That's the first thing we need to do. So this is like a method, and we need to learn the steps. The next thing we do is to add water to balance the oxygens. The first thing we need to do is separate oxidation from reduction by using oxidation numbers. Second thing is we add water to balance oxygens. So how many waters must I add here? It's got 7 oxygens. How many waters must I add? 7 waters. Okay. Then we need to add hydrogens to balance the hydrogen ions to balance hydrogens. So the third thing we need to do is you add hydrogen ions to balance the hydrogen atoms. Okay? Where must I add hydrogens? To the oxidation half reaction? I must add 2 hydrogen ions. How many hydrogen ions must we add to the reduction half reaction? 14. So 14 hydrogen ions to the reduction half reaction, 2 hydrogen ions to the oxidation half reaction. Balance the rest of the elements is the next step. So is the hydrogens are balanced here in the oxidation half reaction. Is the sulfur balanced? Yes. Hydrogens are balanced here. Oxygens are balanced here. Is the chromium balanced? So we need to multiply the chromium 3 plus ion by 2. So the fourth step is to balance the other elements. Okay. The fifth step is to add electrons to balance the charge. Okay, what's the charge on the left-hand side of the oxidation half reaction? 0. What's the charge on the oxidation half reaction on the product side? 2 plus. How can I get at 0? Add 2 electrons. Is it making sense? It's the oxidation half reaction, so it gives off electrons. Okay? Then, what is the charge, the overall charge in the reduction half reaction if I take the dichromate and the hydrogens? What's the overall charge there? It's 2 minus and 14 pluses. 12 pluses. Am I right? And what's the overall charge on the product side of the reduction half reaction? 2 3 pluses makes plus 6s. 6. So how many electrons must I add to this side? 6 electrons will make this part 6 plus, which is equal to that part, then 6 plus. Okay? What's the next step? Balance the electrons. So this one must be times by 3. So it is 3 H2S, 3 sulfur, 6 hydrogens, 6 electrons. And this one is fine then. Then the electrons are the same on both sides of the arrows, so we can scrap them. And on this side of the arrow, there are 6 hydrogen pluses. And on this side, there are 14. So we can say this will be 8. Am I right? Okay. So the net reaction will be in ion form 3H2S plus Cr2O7 negative plus 8 H pluses going to 3S and 2 Cr3 plus and 7 H2O. Because originally we had to add the waters to balance the oxygens, and in the dichromate there are 7 oxygens. So that's how I knew I had to add 7 waters. Because the 14, remember, hydrogen ions, if you have hydrogen ions on both sides of the arrow, you may cancel them out, simplify them, I think you call it in mathematics. You can do the same with water. Reduction half reaction. Yes. For this one, you can look at the table, but not all of them are on the table. That's why I'm using something where it's familiar, we've done it before, but you need the method to do it if it's not on the table. All right. Why is this thing not working? Look there, it's not stopping.